Okay, it's time to hit up the last part of section 4.5. And this is called the rational root theorem, which is reserved for equations and functions that we're presented where factoring is not an option right away. So it provides us with another way of finding solutions. And then you could graph it if you want. We're not even going to bother graphing these. So you can see the rational root theorem is here in front of us. And it's important to denote this ratio of P over Q. So what we want to do is we want to come up with P, which are the factors of the constant term A0. So that will be the constant term that you see at the end of the expression. And that's going to be written as a ratio to Q, which is the factor of the leading coefficient expressed right here with that notation A sub n. Okay? So let's go ahead and do a problem, and I'll explain it as we go. Step number one, I want you to identify P and Q. Okay? So this is P, and Q is right here, which would be 1. Now, what we want to do is we want to write all of these ratios, P to Q. So the first thing you do is you take P, which in this case is 20, and you write all of its factors, preferably in order. So let's think of all the numbers that divide into 20. You got 1, 2, 4, 5, 10, and 20. Now I want you to do the same thing with Q, which is going to be really easy this time. And that's just going to be 1. Now here's where it becomes interesting. So what we're going to try to do is we're going to make a list of all the possible rational numbers. So let's review what a rational number is again. It is a number that if it is converted into a decimal, it would be a terminating decimal, like 0.75, or a repeating decimal. And if it cannot be converted into a decimal, then it is just simply an integer. So the next step is to write all of the possible ratios, positives and negatives, for P divided by Q. And this will give us a list of all possible answers or roots to this equation that we have. So you get the hang of it here. So what I'm going to do is I'm going to match these up. P to Q, that'd be 1 to 1. So that'd be 1 and -1. You list the positives and the negatives. And then 2 over 1, which would be 2 and -2. These are all ratios. And then 4 over 1, which would be 4 and -4. Well, if you keep going through this, it would just be all these numbers. And the list would be much longer if Q had more factors. Okay, so that list right there is important. That contains all of the possible solutions to this problem. Now we know, if you look back up at the original problem, see how it's a degree of 3? Only 3 solutions exist, but at least one of them is on this list. Okay, it's kind of like a game show. There's all the options that you have. The question is, which ones are solutions? Well, if we could find one that's a solution, then we could find the others. So how do we do that? Well, what we do is we do a little guessing and checking. And we have talked about this before, that if we look at our original function, if we find a factor, then that means if you divided into this function, it would give you a remainder of 0. So I am going to use synthetic division, and I'm going to take all the coefficients from this problem. So we've got 1, -8, 11, and 20. And what I'm going to do is I am going to try and guess which one of these would give me a remainder of 0. Now, something to consider. When we do synthetic division, the first number is dropped down, so we know there will be a 1 there. And what would this number have to be right there to give you a remainder of 0? Right, it would have to be, in this case, -20. Now, the reason why I set that up is that may give you an idea of which one of these numbers might work in this situation. Like, will 1 work? I don't know. We would have to test it out. And I guess you could do mental testing and see which number. Oops. Does that one work? Does that work? At least one of these will work, but no more than 3. So just do a little guessing and check it. Now, I'm just going to guess maybe -1 works. Let's go through this. -1 times 1, let's do our synthetic division, is -1. Add those up. Multiply -1, -9, you get 9. Add those up. You get 20. 20 times -1, it gives you that -20. In other words, I've solved this correctly. That was just a pure guess. If that didn't work, I'd go on to a different number. So now the next step is, I know that -1 is an answer, but we also discussed that the degree of this polynomial is 3, so there's got to be 2 more answers. So I guess you could maybe try some more numbers with division, but there's no guarantee the other answers come from this list. They could be something else. So what we do is we rewrite this as a depressed polynomial. So this would be 1x squared. So you don't really need that 1 though, do we? Minus 9x plus 20 equals 0. So that's the depressed polynomial. You remember that from synthetic division. You drop down 1 degree. And we try to solve that. Now, can that be solved by factoring? Okay, this one probably can, but if not, you've got some other resources like the quadratic formula or completing the square. All right, give me 2 numbers that multiply to give you 20, add up to give you -9. What are you thinking? This is what I'm thinking, right? Use your 0 product property, and you have found all the answers. So what I'll do is I'll write this as a solution set. Okay, now you got to remember, we go up here. That's one of our answers because it worked to give us a division with a remainder of 0. And that has got to make sense, everybody. We have 3 answers, and this polynomial is a degree of 3. Problem solved. So the rational root theorem, when you take those numbers P and Q and you write them as ratios, all it does is gives you a list of numbers where one of those numbers, at least one, is a solution, maybe more, and they're all rational numbers. Let's try one more example. Okay, so let's go through this process again. So in this case, there's a polynomial. We could not solve it with factoring. It's just not going to work. You can try if you want. So there's got to be another way to go about this. So what we're going to do, we're going to identify P and Q. So P is 12. Now let's get all the factors. Okay, so there's all the factors of 12. Q is always the leading coefficient. Now this one's going to produce some more combinations because the factors of 10, there's 4 of them this time. So it's going to be a little bit more interesting. You got to be organized with your approach. So what we're going to do is going to be a big list here, I think. We have to list all of the ratios P to Q and stay organized. So what I'm going to do first is I'm going to match up that one with all the green numbers of Q. So 1 to 1, 1 over 1 is 1, right? So there's the first 2 possibilities. And then 1 over 2. See, those are, oops, I didn't mean to do that. Those are rational numbers, right? 1/2 is 0.5, isn't it? So it's a rational number. And then 1/5, 1 to 5. Okay, it's going to take a while to write all these out. And then 1/10 and negative 1/10. So I got 1 done. Now I'm going to list all the combinations for 2. Now some of them may repeat, so you don't have to write them again. So 2 over 1 is the first one. Then 2 over 2 is 1. Well, we already have that listed. 2/5, we haven't listed that yet. 2/10, which is 1/5. If you reduce it, that's already on the list. So we're done with those. Now let's go on to 3. 3 over 1, we have not listed that yet. I got a really long list here. 3 over 2, we haven't listed that. Whoops, gosh. Probably easier just to erase this. Okay, so this will be negative 3 over 2. 3/5. No, we have not listed that. And then 3/10. No, I've not listed that. We got to put that down. Now let's go to 4s. 4 over 1. You get the idea, right? 4 over 2 is 2. We've already listed that. 4/5. I don't see that. And 4/10. If you reduce 4/10, it's 2/5. That's on the list. Let's go to the 6s. 6 divided by 1 is 6. We don't have that on the list. 6 over 2 is 3. That is on the list. 6/5 is not. And then 6/10. That would be 3/5. We already have that on the list. We're done with the 6s. Finally, the 12s. 12 over 1. We don't have that. 12 over 2 is 6. We have that. 12 over 5. I do not think we have 12/5. And finally, 12/10. That would be 6/5. We have that. So we actually have all of our possible answers. Now, that's a huge list, right? The original problem is a degree of 4. That means there are 4 answers to this problem. There's no guarantee all 4 answers are in that list, but at least one is. Which one of those is? Well, this is going to require a little bit of work, right? Let's take that polynomial and let's rewrite it here so we have some synthetic division ready to go. So here's our coefficients. We had 10, negative 11, negative 42, 7, and 12. Unknown number going in there. We know that that 10 will drop down here. And we know our remainder's got to be 0. So this number under the 12 has got to be negative 12. So what we need to do is try to figure out what number from that list will work. And like I said, there's 4 answers to this. Maybe all 4 are in there. Maybe 3 are, maybe 2 are, maybe just 1 is. We have to work through it. So try to figure out which one it would be or what it could be. Okay, so I'm just going to tell you, there are actually two solutions in our list, and it depends upon which one you found first. But through trial and error and me looking through this list, I'm thinking negative half is going to work. Let's go through this. Negative half times 10 would be negative 5. Add those together, you get negative 16. Multiply that to negative half, it's 8. Okay? Add those up, it's negative 34. Multiply that by negative half, and that's 17. Add those up, it's 24. When you take negative half of 24, it's negative 12. It works. That worked. Okay, so we got a remainder of 0. That means we can write a depressed polynomial from this situation. And keep in mind, this number right here, everybody, that is a solution. Okay, that's one of our answers. We need to just find 3 more. So originally this was, let's double check. This was the 4th power, right? Yeah, the degree is 4. So we have to drop this polynomial down 1 degree. Okay, now what we need to do is solve it. Can we factor that? I don't know. I mean, maybe. But I'm going to save us some time and tell you that I've already tried to factor it, and it does not factor. So the question is, what do you do now? Well, what you do is you do another round of synthetic division, which means that if that can't be factored, one of the answers has still got to be in the list up there. Okay, everybody got that? So you can do another round of synthetic division. So let's take these coefficients and let's bring them down here. So we've got 10, negative 16, negative 34, and 24. An unknown root over here. We know when we do synthetic division that 10 will be there. We're looking for a remainder of 0, so we need a negative 24 to appear right here. So the original list that we generated will still work. One of those numbers. Now, what we know is that this one worked. So don't try that again. Now, it's possible it would work again. It would be a double 0. So look through that list of numbers and try to determine which one would work, and try to use some mental math here as you go through it. Okay, so I'm thinking by looking through that list that 3/5 might work. Okay, so one thing to share with everybody is when you do this multiplication, it's easy to do it mentally. 5 goes into 10 twice. 2 times 3 is 6, right? So you could do a little bit of mental math like that to shorten things up rather than using your calculator. So I know that this will be a 6 here. Add those together, you get negative 10. So I know there's going to be a negative number when I multiply. 5 goes into 10 twice. 2 times 3 is another 6. So that's negative 40. And 5 goes into 8 times 3. That's negative 24. That worked. So we know right now 3/5 is another answer from the list. Now, there are 2 more numbers. Are they from that list or not? I don't know. We're going to have to figure this out. Let's look at that polynomial as those coefficients as a depressed polynomial. So this would be 10x squared now. Remember, the other polynomial was cubed. You see it up there? Minus 10x minus 40 equals 0. Okay, let's try to solve this. How about we factor? Let's take out a greatest common factor of 10. We got a problem. That polynomial that's left over cannot be factored. But I told you before, once you get to something that's quadratic, it can be solved. You have options. complete the square, or quadratic formula. Now, because the middle term is an odd number, completing the square would be very difficult to do. It could be done, but I think I'm going to rely on the quadratic formula. So if I remember, A is 1, B is -1, C is -4. So I'm going to set up my quadratic formula. Negative B plus and minus square root of B squared minus 4 times A times C all over 2A. Now, if you remember that little story I told you about before with the quadratic formula, that may help you out with this calculation. Let's get the discriminant. Go ahead and calculate those blue numbers. But I think what we're going to get here is 1 plus 6. It's going to be 17. And here's the deal, everybody. That cannot be reduced anymore. That's your other two solutions. So those did not come from the list. The radical 17, if you change it into a decimal, is not a repeating decimal and it does not terminate. Those are irrational numbers. Let's list all of our answers. So I know we have those two. 1 plus and minus radical 17 over 2. That's two answers. And then what were the other two? Okay, 3/5, which is a rational number. And the original one, yep, -1/2. Another rational number. And that problem is finished. And that is our lesson.